Let's solve this problem using our knowledge on quadratic relations and quadratic equations. A golf ball is hit off a tee. Its height above the ground can be modeled using the equation h equals negative 25t times t minus 8, where h is the height of the ball in meters and t is the time in seconds. When does the ball hit the ground? So let's write the equation. So that's the height of, this is the equation, it's modeled by the given equation. And for the ball to hit the ground, the height must be 0. So what I'm going to do is I'm going to substitute 0 for h and find the corresponding t values. And you have to remember we're going to get two different values. So it starts here, and when the ball reaches the highest point, it comes back to the ground. So there's going to be 2 points at which the height is going to be 0. Let's find what these points are. To solve a quadratic equation which is in factored form, what we have to do is we have to know that the product of two binomials, if it is equal to 0, either both of them are equal to 0 or either this or that is equal to 0. So I'm going to equate both these factors to 0. So negative 25t equals 0. So that's going to give me t equals 0. That's 1. And the other factor is t minus 8 equals 0. And t is going to be 8 seconds. So these are the 2 points at which the height would be 0. It's at time 0 and at time 8. So for the question, when does the ball hit the ground, our answer would be the ball hits the ground after 8 seconds. Okay, let's move on to the second question. When does the ball reach the maximum height? So we want to know at what time the ball reaches this point. So what we're going to do is we're going to write the equation again. H equals negative 25t times t minus 8. To find the time at which the ball reaches the maximum height, we need to change this into vertex form so that we can get the vertex from the equation. That's going to be, let's do that. So I'm going to expand the bracket. So it's negative 25t times t is negative 25t squared. And negative times negative would give me positive. 8 times 25 is 200t. And now, if we have to do completing the square, we know that we have to make sure that the coefficient of the quadratic term has to be 1. So what I'm going to do is I'm going to take negative 25 as the common factor that out, and let's see what's left in the bracket. So it's going to be t squared minus, because I'm taking negative 25 out, it's 200 divided by 25 would be 8t close bracket. Now, what I have to do is what's inside the bracket, I'm going to use these two terms to create a perfect square, 25, and to create a perfect square with the two terms that I have, t squared minus 8t. If minus 8t has to be the middle term, the third term is going to be the square of half of the middle term. So t squared minus 8t. So what I have to add here would be half of 8 is 4. 4 squared is 16. And I cannot just add that number and close the bracket because I've made a change to the terms inside the bracket. So I have added positive 16. So if I subtract 16, that would negate the change. So that means I have really not made any changes. So it's still t squared minus 8t. And I put this to make it easier for me to make that into a perfect square. So what I'm going to do is I'm going to use these three terms to write the perfect square, which is t minus 4 whole thing squared. Now this negative 16 has to be dealt with as well. We have negative 16 here and negative 25 out. So when I take it outside the bracket, it's going to be multiplied by negative 25 and taken out. So that's going to be a positive number. 16 times 25 is 400. So that would be the vertex form. that we were looking for. So when does the ball reach the maximum height? So from the vertex forms, I'm going to write the general equation of a vertex form. So if we have y equals a x minus h squared plus k. If I have an equation in this form, h comma k would be my vertex. So in here, my vertex would be 4 and 400. So for the question, when does the ball reach the maximum height? So the vertex is the point at which the ball reaches the maximum height, where it turns. So the time it takes for it to reach the maximum height is 4 seconds. So let's write the final answer. Therefore, the ball reaches the maximum height after 4 seconds. It really makes sense because the ball hit the ground at 8 seconds. So we have to, it's going to be halfway through when the ball reaches the maximum height, which is at its vertex. Let's move on to the third question. What is the maximum height of the ball? I think we have already found the answer. The height is right here. From B, the maximum height of the ball is 400 meters.